Hello, my name is Ron Fazard, and this is the third part of a 5-part series on how to pack a pump with mechanical packing. This episode we're going to cover the basics of the lantern ring. So let's get started. Lantern rings are one of the most confusing and misunderstood technologies in the pump industry today. The first thing to discuss is why one is needed in a pumping system. Today, with high-tech fibers and lubricants, there is no reason to use a flush for cooling or lubricating packing. The only reason to use a lantern ring with a flush is to keep solids out of the packing set. A clean flush without solids is used as a barrier fluid to keep solids from the pumping media embedding into the packing rings. Solid embedment into packing is one of the main failure modes of packing and can be stopped with a clean flush being used through a flush port. But also realize that if the pump's media is a clean fluid without any solids, no flush is needed. For a barrier fluid to work, it needs to always have higher pressure than the stuffing box. This is very important since sometimes the pressure of the flush is inconsistent, resulting in reversing the flow. Pressure of a flush should be set to 1 bar, about 14 psi, above the stuffing box pressure. The flush pressure becomes the new pressure in the packing, so if the flush pressure is considerably higher than 1 bar over stuffing box pressure, more force will be used to create a seal in the packing, resulting in shorter packing life. Flow into the stuffing box is important and is created by the differential pressures of the flush pressure and the stuffing box. Flow can be restricted by devices like an orifice type restriction, but remember, most flow meters are only restricting pressure, and you could get your flush pressure very close to stuffing box pressure, and that could result in no flow or a backflow situation. One issue that's still seen in the field has to do with misunderstanding lantern ring ports. Sometimes a pump will have 2 or more lantern ring ports. They were designed to get more flow to fill a larger cavity. Many times people are confused and assume this is a flow-in, flow-out pattern that's sometimes seen in a mechanical seal. Flush in a packed pump needs to be higher pressure on the lantern port in the stuffing box and have a lower port open to atmosphere. It does not allow pressure to build up and results in mixing of fluids and solids building up in the packing, exactly what we're trying to stop. Clean flush is also a point to discuss. Many times a flush will not be totally clean. This can result in, again, what we are trying to stop, getting solids embedded into the packing. If a pump has no access to a clean flush, sometimes it is better to go without any flush than with a dirty one. Another major issue with lantern rings is the configuration inside the stuffing box. Many times there will be a set of packing below the lantern ring. These rings below are often forgotten about when repacking and can cause the lantern ring to slowly move into the stuffing box further past the lantern ring port. When this happens, flush water will spray out of the pump and at the same time is cut off, stopping solids embedment. Another major issue with these rings is that they do not provide any sealing but compress rapidly. That results in many adjustments and quicker time before the gland bottoms out, drastically lowering packing life. There are new technologies that actually replace the bottom rings and ensure perfect lantern ring alignment and save time of removal. A bushing can be used but can cause turbulent flow, resulting in mixing of fluids and migration of solids into the packing. EnviroSeal spiral track technology fills the area and also has a built-in lantern port that creates laminar flow in the direction of the shaft rotation. This plus its outer spiral makes for a drastic reduction in solid embedment and longer packing life. There are 2 types of spiral tracks for packed pumps. One is the type P that does not lower flush water unless a restriction device is installed on the flush. And the second is the first that has a built-in flush restriction. That's it for the third video of this series. As always, if you have any questions, feel free to reach out to me for answers. Thank you very much, and goodbye.